Yep. Okay, so homework's done. Pass your folders towards the center people, face the same way, passes to the front. And we're doing 6.3.
Oh, sorry.
Oh. Alright, so what we're doing is binomial radical expressions. Binomial radical expression. Okay. First thing we're going to do is multiply. So we're going to simplify. So we're going to do 3 times square root 5x minus 2 times square root 5x. So when what's underneath the square root is exactly the same, that's when you can just add or subtract. Okay, so what do I get? Square root 5x. If it helps you to put the 1, because what we're doing is 3 minus 2, you could put the 1, but you don't need to put the 1. Alright, so that's it. So let's say a couple quick, easy examples involving that stuff. So let's say we have 6x squared square root 7 plus 4x square root 7. So let's just think about this. Would you add that together? No. So you can't do anything. Stay as it is. The directions just said simplify, and you can write it already is, or if you want to write something like that, but you don't need to write anything. You could just leave it.
Did you write it as 6x squared plus 4x root 7? Or is that
Yeah. Because if you were to write square root 7 right here, right, then you're missing the square root 7 from right here.
Okay.
Yeah, that's why. That's a good question. All right, so let's do another, point out all the little tricks they're going to play on you. So it's got 12 cube root 7xy. And then we're going to do minus 8 fifth root 7xy. How do you simplify? You don't. It is simplified. Why? Because cube root, fifth root, so you're done. Can't do anything. Okay? So it's got to be the exact same underneath the radical and the exact same index to be able to simplify. Alright? So that's every trick they can play on you. Well, most of them anyhow. Alright, so let's do square root of 12 plus square root of 75 minus square root of 3. I love that. Simple 2. Square root of 12, did I say plus? Square root of 75 minus square root of 3. So when they give you a problem like this and you have to simplify, what you got to do is break down the square roots. And because I've got this lone square root of 3 over here, we're probably going to have square root of 3 here in some form or another. So what's square root of 12 divide into? 4 and 3, so that becomes 2 square root 3. All right, how about 75? Square root of 25 and 3. So we're getting those numbers from the list of x squareds, right? 25 divides into 75. So 25 and 3. And this one's already done. So it becomes plus 5 square root of 3 minus square root of 3. So 2 plus 5 minus 1 is essentially what we're doing. So 7 minus 1, 6 square root of 3.
Do you ever add what's under the radical?
Never. 2 plus 5 is 7, minus 1 is 6. Okay? Good, good? You want to do another like that, or are you good? Alright. Not yet. I've got like 3 more big examples. So we're going to do 4 plus 2 root 2. Times 5 plus 4 root 2. So you got a FOIL essentially. Some of you like doing the little box thing. Makes it easier for me to give you partial credit if you do the little box thing. If you like foiling better, more power to you, foil. So 4 times 5 is 20. 4 times 4 square root 2 is 16 square root 2. 5 times 2 root 2 is 10 root 2. And 4 times 2 is 8. Root 2 times root 2 is root 4. So this becomes 8 times 2, which is 16. Then all you got to do is combine like terms, 20 and 16, and 10 root 2 plus 16 root 2. So 20 plus 16, 36, and then plus 10 and 16, which is 26, root what? Good. When you add them, you leave what's under the square root alone. When you multiply them, that's the difference, okay? So that's your final answer here. Okay, so now we're going to multiply conjugates. Go ahead. Combine like terms diagonally, yes. Yep. How about we do, well, we're going to do one exactly like it right now. Except we're going to multiply so let's say we have 5 minus square root 7. So when we write the conjugate of this thing, all we have to do is switch the sign in the middle. Everything else stays the same. So the sign was a minus sign, now it's a plus sign. And then we'll do the box thing again to multiply. So 5 times or 5 negative square root 7, 5. Grayson, upper left, upper right,
5 root 7.
alright, let's get people set. Matty Gailey, lower left.
Negative 5 square root 7.
Okay, and how about Brody, lower right. Square root. Multiply 7 and 7. So negative square root 49, and square root of 49 is 7. So when we multiply the exact same thing underneath the square root, you can just write this. You don't have to show this intermediate step. I'm totally fine with that. Okay? So then we just combine like terms. So when you multiply by the conjugate, what happens to the middle two terms? They're always going to cancel. So when you multiply by the conjugate, you don't even have to write these middle two terms if you want. You can just go 5 times 5, 25, negative root 7 times positive root 7 is negative 7. We do 25 minus 7, which is 18. Okay, let me just write that out so you can see it. So if we have 25 minus 5 root 7 plus 5 root 7 minus 7. Right, these middle two terms, when you multiply it by the conjugate, will always cancel. So 25 minus 7, 18. Done. Any questions? All right, we're going to do 2 more of the last type of example. You're going to have fractions with square roots, numerator, denominator, that you have to cancel. Okay, so first we're going to do, let's do 2 root 7 to 5. So 2 root 7 over square root of 5 minus square root of 3. So essentially what we're doing here is rationalizing the denominator. And to rationalize this denominator, we got to multiply by the conjugate. So Stephanie, what's the conjugate? Switch the sign in the middle, that's all you got to do. Square root of 5 plus square root of 3 over square root of 5 plus square root of 3. So we're going to treat this and just distribute the 2 root 7 into the parentheses. Okay. So we're going to do 2 times square root of 7 times square root of 5. Jane, what do we get? Good. 2 times square root of 35, and then we're doing 2 root 7 times square root of 3. Anna, what do we get? We're doing 3 square root of 7 times square root of 3. Perfect. Okay, and then because we multiply by the conjugate, if you think about FOILing, these bottom two, outside, inside, will always cancel. So all we need to think is square root of 5 times square root of 5 is 5. Square root of 3 times square root of 3, net minus 3. So if you need this intermediate step, it becomes square root of 25 minus square root of 9. which is really just 5 minus 3. Alright? So, you got to write this as two separate fractions because stuff cancels. So we got 2 square root 35 minus 2 square root 21 over what? 2. Right? We write it as two separate fractions so you remember to cancel those. So you get square root 35 minus square root 21. It should be a plus. Thank you. Well, it's a plus the whole time in the first place. Right? Because they're multiplied by positive. Right there. I just creatively switched it in the Now, I just want you to realize because you'll probably get some homework problems where you can still simplify these square roots. So just be aware you may have to simplify the square roots. All right, one more problem. I'm going to do like what would be a nasty one from your homework. So let's do what's that? We're going to do example 5b, 44x squared over square root of 11 plus 3. Yep. So first thing we got to do is simplify square root of 44x squared. So square root of 44 divides into what? Square root of 4, square root of 11. So it becomes 2 square root 11. What's the square root of x squared? X. So this top becomes 2x square root 11. So we have to multiply, let's just rewrite this part. Now we have to multiply by the conjugate. So what's the conjugate? Yep.
11's not cancel out.
So why can the 11s not cancel out? Right. Because if we have 2 over x plus 2, would you cancel those 2s? No. So it's the same rule, just more strange, basically. Okay? Good question, no? All right, so we're going to multiply, what's the conjugate here? Square root 11 minus 3 over square root 11 minus 3. So now we got to FOIL that thing. We're going to distribute up top and kind of FOIL the bottom. So 2x square root of 11 times square root of 11. Right? Multiplying these first two terms. Square root of 121. Square root of 121 is 11. So 2x times 11 is 22x. Okay, I'll show those steps. I just wanted to work you guys through that. That's good. So 2x square root 121. X square root 121, which is 2x times 11, which is 22x. Okay? And then we're doing 2x squared root of 11 times negative 3. Negative 6x square root 11. Huh? What? Yeah? No, from the last problem, yeah. We came back for a little more. Okay, so square root of 11, right? Because we're multiplying by the conjugate here, Square root of 11 times square root of 11 is 11. And then positive 3 times negative 3 is 9. Multiplying, right? So 11 minus 9 is 2. So now I'm going to write it as two separate fractions. So we have 22x So we have 22x over 2 minus 6x root 11 over 2. And then you just got to reduce those two fractions. So it becomes 11x minus 3x root 11. So that's as bad as it gets. That would be like the hardest problem on your homework. Yeah. You good? All right, your homework's on the board. It's page 378, 11 through 49, and 51 and 52.